In this video, we're going to write a C program to remove the duplicate elements from an array. So if we have an array like this, int test is equal to 1, 2, 3, 4, 2, 1, 5, 6, 7, 8, we would say that in this array, 1 and 2 are duplicate values because we have multiple occurrences of these values in the array. What we're going to do is remove all but the first occurrences of the duplicate values from the array. So after running our program, we want to have the array that looks like this: 1, 2, 3, 4, 5, 6, 7, 8. Because this array is actually smaller than the original array, what we're going to do is include stdlib.h so that we can dynamically allocate space for an array that's just large enough on the heap. This library includes the functions malloc and realloc and free that will allow us to do that. We'll also include stdbool.h. So that way I can create and use a bool variable. Now the function that's going to do this work for us is going to be called remove duplicates. It's going to return a pointer to the new array that's been allocated on the heap. The function will accept as an argument the original array and the length of that array. Now the length of the array may actually change because of this function. What we're going to do is use pass by pointer, or what's called pass by reference, to return the new length of the array. So we're going to have int star new length. So we'll copy and paste this and then provide a definition of the function down here. And the first thing we'll do is use malloc to allocate enough space to store the largest array necessary. And the largest array necessary is the array where every element is unique. There's no duplicate elements. So we'll say int star new array is equal to malloc length times size of int. So what we're doing here is using malloc to allocate space for an array that's as large as this array. We're multiplying length by the number of bytes it takes to store an int. This will allocate enough space to store a new array that's as big as the original array. Now, what we're going to do though is resize this later using realloc. So once we've identified how many duplicates are in the array, we then know how large this new array really needs to be to take up the minimum amount of space possible. We're going to use realloc to resize and shorten the array at that point. So what we're going to do is keep track of how many unique elements we really have. We'll create a variable called unique count to help us do that, and we'll initialize it to 0. Next, what we'll do is go through the original array one element at a time. If that element's value is not in the new array, that means it must be the first occurrence of that value. And so we'll add it to the new array and we'll increment unique count. If the element's value is already in the new array, that means it's not the first occurrence of that value. If that's the case, we're not going to add it to the new array and we're not going to increment unique count. By the end of this process, new array will contain the original array's elements with the duplicates removed. So first we'll make an outer loop that's going to have a counter variable I go from 0 up until the length of the original array. Next we'll make an inner loop. And this inner loop is going to loop through the elements in the new array to see if any of them are a match for the element we're currently looking at index I in the original array. If a match is found, that means this element is a duplicate. We're going to start off with the assumption that this element is unique. We'll create a bool variable called isUnique, and we'll set it equal to true to assume that the element is unique. If we find a match, we're going to set it to false to acknowledge that the element is not unique. Next, we'll make a loop with a counter variable j that's going to go from 0 up until the unique count. So unique count is also going to keep track of how many elements are in the new array so far. So what we're going to do is check to see if the element at index j in the new array is equal to the element at index I in the original array. If this is the case, we can set isUnique to false. because we've identified that this element is a duplicate value. We'll also use break to stop this inner loop early, because once we've identified that this element is a duplicate, there's no need to keep looking. Now, if this element is unique, then we're going to add it to the new array. So if isUnique is true, then we're going to add the element to the new array. So we'll say new array at index unique count, which is keeping track of how many elements are in the array. We're going to set it equal to the original array element at index I. Then we're going to increment unique count. So when this outer loop is done, the new array will contain the original array elements with the duplicates removed. And at this point, we now know how large that new array really needs to be, because we've used unique count to keep track of how many unique elements there really are. So what we'll do is resize that array using realloc. Now it's possible that every element in the original array is unique. If that's the case, unique count will equal length. So we're only going to resize the array if unique count doesn't equal length. So if that's the case, we're going to use realloc. And what realloc will do is reallocate space on the heap. We're going to give that space a new size. When that reallocated space is given to us via a pointer that's returned from realloc, it's going to contain the same data as in new array. It's just going to be resized so that we're taking up a smaller portion of space on the heap. We're not using more space than is necessary. So we'll set new array to point to what's returned from realloc. We're going to pass realloc new array and the new amount of space we want on the heap. So we're going to say unique count, the number of elements in the new array, multiplied by the size of an int. So how much space is needed to store an integer. Next, we'll use our pointer parameter new length to return the length of this new array, which is unique count. So we're going to dereference new length. We're going to go get what new length is pointing to, and we're going to set it equal to unique count. And then finally, we can return the pointer to our new array on the heap. So that should be it in terms of the function. Let's test it out now. So in our main function, we'll create a variable called afterLength that's going to be an int. It's going to store the length after the duplicates have been removed from the test array. Then we'll call remove duplicates with our test array and the length 10 and the memory address, in other words, the pointer to our afterLength variable. It's going to return a pointer to the new array on the heap. So we're going to store that in a variable called after that's going to be a pointer to an int. After this is done, we'll print out the array elements to make sure the removal actually happened. So we'll make a loop with a counter variable I, where I goes from 0 up until after length, incrementing by 1. And then we'll print out each element with printf after %d is equal to %d\n, and we'll output the index of this element with I and the value at that element's index with after at index I. And then finally, we're going to use free to free the dynamically allocated space on the heap that after is pointing to. So we can save this and try to run our program. Build failed. Let's see what I did. Oh, I misspelled isUnique. So I'm going to fix that. I'll copy this, paste it here and paste it here. And I also misspelled unique count here. So I'll copy this, paste it here, and we can save it and run our program now. It says build succeeded. And let's see if we get the correct array. And we do. We can see that is our original array with the duplicates removed. So this is how we can write a C program to remove the duplicate elements from an array. Check out portfoliocourses.com, where we'll help you build a portfolio that will impress employers, including courses to help you develop C programming projects.